Isotopes. First of all, write the definition of isotopes. Later we will understand surely. So make it. Isotopes are the atoms of same element. That is very important. This is the most important keyword. Same element. So same element means, can you tell me who is always remains constant? Suppose I have taken a particular element. Somebody remains constant always. We will decide with the help of that. We will decide what is the given atom. Anyone? It is different for every element, and with that only we can decide either given element is what. Anybody?
Atomic numbers.
Atomic number.
Good. That's what it is. So if you have taken a atoms of same element, then who will be always remains constant? Can you tell me? Atomic
number.
Atomic number.
Yeah, that is what you have to remember. Same element have same element which have same atomic number but different mass number. Now I am saying somebody is always remains constant. Who is always remains constant? Atomic number. Is it yes or no? So atomic number means we all knows that atomic number is equals to what, guys? All of you.
Number of protons.
Understanding? Number of protons. And same way, mass number means, what is the mass number? Yes, please. Mass number means what? All of you.
Proton plus neutron.
Number of protons plus number of neutrons. So I'm saying that now you might be notice it. Protons is always remains constant. So who is not constant in isotopes? Everybody. Isotopes, I'm saying that number of protons is always equal in any isotope. Then who else is not constant? Number of neutrons. That is what you have to remember. Clear? So isotopes belongs to same element. That is the most important thing you have to remember. Isotopes means same element, atoms of same element which have same atomic number but different mass number. That is what meaning of isotopes. So isotopes means two words you have to remember, totally three words. Atoms of same element with the same atomic number, but what number different, guys? But different mass number. That is called as isotopes. Now, the word isotope is taken from actually a Greek word actually. So isotopes. All of you remember iso, it is actually a Greek word. Iso means same. What do you mean by iso? Iso means what? Same. Tope. What do you mean by tope? Means place. Like we can say same place. That is what is the meaning of that. All isotopes have same place in the periodic table. That is the meaning of isotopes. Are you clear? Mitakshri? Abhirami?
Yes, sir.
So iso means same, tope means place. So if you have taken all the isotopes are present, as I told you, in a periodic table, observe very carefully. This is what how the periodic table looks like. You all studied. Do you remember that? Long back I have taught you. Last column, who will be present? 18th group. 18th group who will be present? Group number 18. Inactive gases called as
Noble gases.
noble gases. Understanding? You all should know noble gases. So if you have taken, who is the noble gases? Can you tell me? Helium, neon,
Helium.
argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, radon. They are called as what gases? Noble gases.
Noble.
Clear?
Well,
So
yes.
now, what do you mean by isotopes means? Remember, for example, we all know carbon. So carbon, what is atomic number? Fastly,
6, sir.
6. So it will come in the same particular here. It will come, okay? All, maybe it is having a different mass number. But remember, this periodic table is designed only based on, anybody, can you tell me what is that? It is designed based on what? Atomic number or mass number?
Atomic number.
Based
Atomic
on
number.
not mass number. All of you remember, it is only purely designed on based on atomic number. Are you clear, everybody? Because who is only unique in an atom? Number of protons. So protons are every different atoms of an element. Number of protons is not constant. For a given element, the number of atoms, whatever the number you have taken, if it is the same element, every atom who is remains constant, guys. If it is the same atom, if it is the same element, atomic number means number of protons is always remains same. So that is why even though their mass number is not constant, all the element, all the isotopes is represented in the single place, same place in an periodic table. Because who is remains constant? Harish? Even though they're having mass number is different, who is constant? Atomic.
Atomic number.
That is why they have been placed in the same place in a periodic table. So that is the meaning of isotopes. Isotopes means same. Iso means same. Tope means place. Kept in a same place. That is the meaning of it. Right. So all the isotopes. So all the isotopes have same place in periodic table, same place in periodic table as the atomic mass is same or different, everybody? Atomic mass is what? Same or different?
Same.
Atomic mass is same. That is, sorry, atomic number, guys. Sorry, atomic number, not mass. Atomic number is same. Z is same. Are you clear? Yes, please. Now, also remember, this all the isotopes, they have similar chemical properties because as we all know, number of protons are same means some other also same. Can you tell me who is same? I want to know from you all people.
Number of electrons.
Number of electrons also. Now, number of electrons are same. Electronic configuration same or different? Mr. Aswin, Harizeras, if number of electrons are same, electronic configuration is same or different? That's what my question. Sanjay?
Same, sir.
Same. So that's why their chemical properties also same. Understand, Harijeras? Very, very important. So all the isotopes, they have similar electronic configuration. So that same chemical properties or different chemical properties. Everybody?
Same chemical properties.
Chemical properties, right. The isotopes have same chemical properties as they have similar electronic configuration. containing same number of, Johan, are you writing? Same number of valence electrons. Are you clear, Mr. Kaushik, Aswin Balaji? Everybody, anything doubt you can ask. But you remember, their mass number is same or different? Their mass number is same or different?
Different, sir.
Different. So their physical properties are not same. They have different physical properties. What do you mean by physical properties? Any one example of physical properties? Abhirami, Dakshri, any one example? Gokul, Akilan, any one physical properties? What you studied? Any physical properties you never studied? Like,
Valuable.
yes, melting point, boiling point, densities, that is.
Temperature.
Yeah, melting point, boiling point,
Volume,
yeah, volume, density. Volume remains almost constant because neutrons are present in inside the nucleus, correct? So then it's not much affected. Density is due to what? Atomic number or mass number? Due to different mass number or atomic number? Everybody.
mass number,
Due to different mass number. Keep it in mind, physical properties is depends on mass number or atomic number. Physical properties, mass number. Chemical properties,
atomic number,
atomic number. Keep it in mind that. Write it. If you are okay, then I'll give you totally 4 examples for isotopes. All the 4 examples we'll study and later we'll go to fraction atomic mass also. Shall we start? Everyone?
Yes, sir.
Yeah. First example. Now, hydrogen. Hydrogen. There are 3 isotopes of hydrogen. Everything is very important. The one and only element which does not have no neutrons is hydrogen only. That is also one of the isotopes of hydrogen does not have neutrons. Are you clear, everybody? What I'm saying? In exam, even they will ask you, write isotope of an element which does not have any neutrons or 0 neutron. Clear? All of you? So hydrogen, there are 3 isotopes of hydrogen. There are 3 isotopes of hydrogen having, who is having same? Having, who is same, guys?
atomic number,
Yeah, having same atomic number, but different mass number. So what is the atomic number of hydrogen? Anybody?
1, sir.
You all know, correct, right? The atomic number of hydrogen.
One, sir.
Yeah, I'll say atomic number of hydrogen atom. is 1. First isotopes. Structure also I will draw. You have to draw structure also, even in exam also. First, A. You can see H1, 1. Next, B. H1, 2. C. H1, 1. So now, totally how many isotopes? All of you?
3 isotopes.
How many isotopes? 3 isotopes. Now, can you tell me, in every isotope, I want to write to you people from down itself, now itself, number of electrons. Tell me fastly. Number of electrons, how many? 1. Number of protons, please. 1.
1.
Now, number of neutrons. Here, see that only 1 is there. That is self proton. So, number of neutrons are how many?
0.
0. Next, same way. Number of electrons, 1. Number of protons also. Number of protons also,
1, sir.
1. Next. Now, protons are 1 means neutrons are how many? Check it here. 2 minus 1. Number of
1.
neutrons, 2 minus 1, which is equals to what? 1. Same way here. Number of electrons. Fastly tell me here 3 guys, not 1 it is. 3 it is. Now tell me number of electrons. 1.
1, sir.
Number of protons.
1.
1. Number of neutrons. 3
2,
minus
sir.
1 is equals to how much guys? Respond.
2.
That
2,
is
sir.
what it is. So in isotopes, who is not constant? Number of
Neutron is not constant.
Number of neutrons are not constant. But who is always constant? Electrons and
Electrons and protons are
Proton.
electrons and protons are always constant. So one example, if you have been clear, then everything you can do it very well. Now, I'll draw structures also. So remember first one called as protium. What is the first name called as? All of you, protium. Or we can say, Hari, this is very important, Hari. Simple hydrogen. All of you remember that. Mr. Omar, are you writing? Simple hydrogen. Second one is called as deuterium. 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 Or we can say heavy hydrogen. What is his name?
heavy hydrogen.
Last one, tritium. Tritium, or we can say radiohydrogen. Very, very important. These are the 3 isotopes. Anyone having any doubt? Let me know. Are you clear, guys?
Yes, sir.
Yeah. First one, protium, simple hydrogen. So what is the isotope of an element which does not have any neutrons? What is the name? Anyone?
Simple hydrogen.
All of you, a simple hydrogen. What is the name called as? Simple hydrogen. Shruti?
Protium.
That is what you have to remember. Okay. Now you can draw the structures. So you all can make it. So I'll draw the structures. You can see 1 H11, H12, H what? 1, 3. Okay. So hydrogen, how many electrons are there, guys? Fastly. How many hydrogens? How many? Only one cell it is having. So let us make that cell with the properly, beautifully. I'll make so that you all will be fine. Okay. Yeah. So 3 hydrogens. I'm taking three. So be very careful. And I'll put one nucleus also now. Draw nicely, neatly. Because exam also you have to draw beautifully. You cannot draw your freehand diagrams. Okay. So now that is what all atoms should be in same size. All atoms should be in same size. Now first one, tell me number of protons. Number of protons here.
1.
One,
One proton. And neutrons.
0.
Zero neutrons. And electrons. How many
1, sir.
electrons?
1 electron.
One electron. Here also one electron. Number of protons fastly.
Number of proton 1.
One proton. Number of neutrons. One neutron. Same way. Number of protons here. One proton. Number of neutrons. All of
2
you.
neutron.
Two neutrons. And electrons are remains constant. Make it fast. Any doubt? Anyone can ask. Clear, guys?
Yes, sir.
So what is the name of this one? First one, all of you.
Protium or simple hydrogen.
Protium. Second one,
Deuterium.
deuterium. Third
Deuterium.
one,
Radium.
tritium. Do it fast. Clear, everyone? Next. This is the first isotope example. Next, carbon. Carbon, your book, they will give you 2, but actually 3 isotopes are there. Let us learn the 3. No, nothing will happen. But your book only 2 they mention. Middle one is missing. But actually the isotopes of carbon is 3. So let us start now. Shall we start? 2. Second example is carbon. So carbon also, how many isotopes are there? 3 isotopes. All of you remember that. The first one, there is no names for this one. Okay, directly we can go with that. First one, C612. Second one, C613. Third one, C614. Clear? So C14 is only called as radioisotopes. Please remember that. We have use of this one. We will study applications of radioisotope. By the time we will study this. Okay. Radioisotope of carbon, we will say that. So what is the more standard isotope of carbon? We used this one in 3rd chapter for calculating something. Can you tell me what is that?
Atomic mass.
For calculating something. Can you tell me? Everybody.
Atomic mass.
Atomic mass. That is what? Carbon 12. Do you remember every time we say carbon 12 for calculating atomic mass? Yes, Mr. Harijaras? Google. Yeah, carbon 12 is the more standard form of standard isotope of carbon. Remember that. And this C14 is present in plants. Keep it in mind that. This is the second isotope. Please make it, everybody. So now, let us write. Everybody should join back again. Cannot relax. Now, let us say number of protons and number of electrons fastly. Electrons, protons, neutrons. First one. Electrons, 6. Protons also 6. Neutrons, 12 minus 6 is 6. Next here, electrons, protons, and neutrons. You should tell me fast. I should not. Electrons are 6, protons are 6, neutrons 13 minus 6, which is equals to 7. Same way, electrons, protons, neutrons. Exam also you have to write like this only. Number of electrons 6, protons are 6. Neutrons how many, guys? 14 minus
8, sir.
8, sir.
That's all. Write it fast. Meeting is going to end. Join back. 2 more examples I'll give. Later we'll wind up. Later remaining things we'll study next. Do it fast. So what is the isotopes of carbon? Carbon 12, carbon 13, and carbon
14.
Carbon 14. Remember that.